Students, let's discuss exercise 6.5 seventh sum. Prove that the sum of the squares of the side of rhombus is equal to the sum of squares of its diagonals. Actually, here I took the rhombuses A, B, C, D, their sides. Okay. At the same time, here see this, the diagonals are intersecting at point O. Already we know the properties of rhombus. The diagonals are each other intersecting at a right angle. Okay, so diagonals are bisecting each other at a right angle. So that is the property, one of the property of rhombus. Actually, here we are going to apply the property. So here given sum of squares of sides equal to sum of squares of their diagonals. Okay, so see here the triangle AOB is right angle triangle. So here we are going to take all the right triangles AOB, AOD, COD, BOC. Now I am going to take the right triangle AOB. So here which is hypotenuse AB. So AB square equal to OA square, OB square. So that is first condition. And the second one BC. Here this angle is right angle. So BC square equal to OB square plus OC square by Pythagoras theorem. Second condition. So similarly third and fourth. CD square equal to OC square plus OD square and AD square equal to OA square plus OD square. Okay. So next add left hand side and right hand side. Then only we can prove that sum of squares of all the sides is equal to sum of squares of their diagonals. Okay. So if we add a right hand side all the diagonals AO square, OB square, OC square, OD square are repeated two times. Okay. So I took 2 of OAO square plus OB square plus OC square plus OD square. Okay. So AO square, see this AO square, AO is half of AC. Actually here we need to put that sum of squares of diagonals. So see here AO square is half of AC square. For that purpose only here I took AC by 2 the whole square, or it's and the next. So BO square is BD square, BD by 2 the whole square. Similarly OC square is AC by 2 the whole square. OD square is BD by 2 the whole square, because half of BD is BO and OD. But you should not take AO square plus OC square equal to AC square. You will not be get the proper measurement. Okay, should not take AO square plus OC square equal to AC square. That is false. Then now see here AC by 2 the whole square plus AC by 2 the whole square we can take 2 times, and BD by 2 the whole square plus BD by 2 the whole square we can take 2 times. So we can take 2 as outside. So AC by whole square by 2 plus BD by BD the whole square by 2. So here 2 is common. So take LCM. Then the 2 will be cancelled. So remaining AC square plus BC square. Actually here we need to prove that the sum of squares of all sides of rhombus is equal to sum of squares of their diagonals. So AC square BD square is sum of squares of diagonals. So hence proved. Students, let's discuss exercise 6.5 eighth sum. In the following figure, O is a point in the interior of a triangle ABC. OD is perpendicular to BC, OE is perpendicular to AC, and OF is perpendicular to AB. Show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus CE square. And the second subdivision, AF square plus BD square plus CE square equal to AE square plus CD square plus BF square. So see here, here we need to prove that OA square plus OB square plus OC square. But here, is it possible to take OE, OE, OF, OD? But here given OA square. So for that, here we need to construct OA. Okay. Here we need to join OA, OB, OC. So see that if we joined OA, OB, OC, you will be get like this figure. Okay. So for that, first here we need to find out that OA square. So OA is, see this OA and OE, AE. This is looking like a right angle triangle. By using Pythagoras theorem, find out OA square. So OA square equal to, we can find out OF square plus EF square. And similarly, take BOD. The triangle BOD. Here the angle D is right angled. Okay. So OB square equal to, OB square equal to OD square plus BD square. OC square. OC square equal to OE square plus EC square. We can take OD square plus CD square also, but whichever we want to prove here in this first subdivision. Okay, first subdivision, whatever they given, that square of sides, that only here, here we took. So adding these equations, okay, the left hand side and right hand side. So OA square plus OB square plus OC square. In the right hand side, similarly OF square plus AF square, OD square plus BD square, OE square plus EC square. Then actually here we need to prove that OA square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus AC square. So for that, here I transposed some values to the left hand side, OD square left hand side and OE square left hand side, and then OF square I transposed left hand side. Okay. So finally I got OA square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus AC square. The second condition, we need to prove that AF square plus BD square plus AC square equal to AE square plus ED square plus BF square. Okay. So AF square. So see here, which is AF square. So AF square equal to OE square minus, so AF square equal to OA square minus OF square. So from the diagram, and BD square equal to OB square minus OD square, and EC square equal to OC square minus OE square. But here we need to prove that to the right hand side is AE square plus CD square plus BF square. So AE square equal to OA square minus OE square. So here take OA minus OE. So OA square minus OE square. And the next we need to prove that CD square. So here I took first OA and OE square, and the next we need to prove that CD square. So CD square equal to OC square minus OD square. So OC square minus OD square, OC minus OD. Next, we need to prove that BF square. So BF square equal to OB square minus OF square. So OB square minus OF square. So OB square minus OF square. So now we can say that OA square minus OE square, AE square plus OC square minus OD square is CD square plus OB square minus OF square is BF square. Hence proved.